Welcome. So today we're going to take a look at a very common interview question. Also a very simple one, but can be very deceptive. I've actually ran into this one during an interview. Glad I went over these examples. Now, 88 on Leetcode, merge sorted array. Let's take a look. Let's read over this description quickly. Merge sorted array. It's classified as easy, but as you know, no Leetcode questions are actually easy. You are given two integers arrays, nums1 and nums2, sorted in non-decreasing order. That's very important. And two integers m and n, representing the number of elements in nums1 and nums2, respectively. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. So that's why you get m and n to tell you how many items are in the array, because you need to put everything in place into nums1. That's also the tricky part of this question, because how are you going to keep the stuff in nums1 without copying it somewhere else or anything like that, and merge the other array nums2 into that? Let's have a look at some examples. So we've got nums1 and nums2. This m equals 3 over here means that we want to keep 3 of the items in this array. These items here are just placeholders, so we need to shift numbers around inside of this array without copying it anywhere else. We have to take the items from nums2 and intersperse it in the correct order in this array. This output is 1, 2, 2, 3, 5, 6. So it's in increasing order. Number 2. So we've got 1 in there and an empty one for nums2. Meaning if we didn't do anything, it would just return that array as is. So these are more edge cases. Nums1 is just a placeholder and it's telling us that m is 0, so we shouldn't worry about any of the elements in there. Nums2 has the value and it's got one value in it. The output is 1. Okay, so let's recap. The tricky part here is we need to mutate the nums1 array. We can't copy the values anywhere else. We need to take the values from nums2 and intersperse them in the correct order. As with all these questions, there is actually a pretty easy way to do it. It's difficult to stumble upon, but I'm going to show you, and hopefully it will help you in your interview. Let's try and draw this out and see how to solve this. So this is the example input given to us by Leetcode. We can see that our arrays have 1, 2, 3, 0, 0, 0. Those last 3 are placeholders because m equals 3 and n equals 3. The trick in this question is to work backwards through these arrays. Now, we're going to assign 3 variables. We're going to have I, j, and k. Now, we're going to try and get the last index in this array containing a valid variable, a variable that we want to keep. So if we just think about that, let's use orange over here. We want to keep that one here. And let's use blue for this one here. Okay? So how do we use m to give us that index? If we just eyeball that, m is 3, arrays are 0 index, so we want m1 is 1, will give us index 2 in here, which would result in this number 3. So let's initialize it like that. We say that I equals m minus 1. So that results to 2. We do the same for j. We say j equals n minus 1, and that gives us 2. Excellent. Now, what is k? Well, K is our merge index. We're going to move a pointer through our first array. I just noticed that I used the wrong names here, so let's fix that quickly. We want to keep a merge pointer in nums1. And we started off as the length of nums1 minus 1, just to get the last item in there. So K equals 1, 2, 3, 4, 5, 6 minus 1 when we start out. And let's make that one green. Okay, let's add a little key on here. So let's use this, go backwards from our values, which are already sorted correctly in the separate arrays. Then we look which one is bigger. We take that one, we put it in the merge index. The array that we took it from, we can decrease its pointer so that we can move on to the next item. Let's start doing that. So in this one, where we've got 6 and 3, 6 is clearly bigger than 3. So we want to erase this one, and we want to put 6 in there. Now, because we took this item from this index, we need to decrease this pointer. So I'm going to do this and move it on to this item. So what we're essentially doing is we're saying j minus minus. So it's not 2 anymore, it is 1. We also want to decrease k. It used to be 5, now it's 4. Let's just move it on here. Right, okay, so now for this merge index between 3 and 5, which one's the biggest? You've got it? It's 5. So we need to go and erase this and then put 5 in there. Now we do the same thing we did earlier. We need to decrease the index from the array where we grabbed an item, and we need to decrease the merge index. So j now becomes 0, and this gets decreased to 3. It's green. We're targeting this index now, and j is blue. We've made it all the way to index 0 of this array. Now, between 3 and 2, which one is bigger? It's the first time we're going to take from the nums1 array. We're going to take 3 and stick it in there. And because we took from nums1, our pointer for nums1 needs to be decreased for the first time. So it used to be 2, it's now going to be 1. And k, whenever we find a match, we need to decrease it. So that is 2. Let's just update our pointers here, our visual pointers. Goody. So now we go and say between 2 and 2, which one's the biggest? Well, they're the same. What we want to do is we want to take preference from the nums2 array. On this index, this merge index, we want to change that to 2. Let's do the same as we did the previous time. We're going to decrease both our merge and our array pointer. So this one used to be 0. So now it's minus 1. This one used to be 2. And now it's 1. But because one of our pointers are invalid here, meaning it's lower than 0, it doesn't point to anything in the arrays, we're done. And let's have a look at the values in here. 1, 2, 2, 3, 5, 6. And that's exactly what we wanted to end up with. Now let's go and do this in the code. First thing we want to do is initialize our variables. So let's go and say let I equals m minus 1. Let j equals m minus 1. And let k, our merge index, be nums.length minus 1. Great. Now let's create a while loop where we say if j bigger than equals to 0. Let's think about an example where we get an empty array for nums2. Remember, j is the pointer to nums2. If it's an empty array, we're done. There's nothing to merge, and we won't ever enter this while loop. So it makes sense to just check the nums2 pointer in this condition. And what we want to do in here is we want to say that if I equals smaller than 0. So this is when we've gone all the way through our items in the first array, meaning that maybe it didn't have any items, or we've looped through it on previous times, but we've still got values in nums2 that we make it in here. Or we say that nums2, using our nums2 pointer j, is bigger than nums1, you guessed it, I. So this logic means that, hey, we actually want the value from nums2 to win and go to wherever our merge index is. Remember, we want to add the items into the nums1 array. So we go and say nums k, which is our merge index, equals nums2 j. All right. Now, because we took an item from nums2 using its j pointer, we need to decrease it. Okay. Now, let's handle the inverse here. We know that I still has a valid pointer, because otherwise it would have been caught by this piece of logic. And we know that the value at I from nums1 is actually bigger, because otherwise this clause would have been met. Then all we need to do is say nums1, okay, our merge index equals nums1 I. And because we took from nums1, we now need to decrease the pointer to our nums1 index. For both these scenarios, we need to say k minus minus. All right, let's give that a run. I just made a mistake in there. It's actually nums1, as you saw me doing it throughout this whole recording. All right, so our test case is passed. Now let's submit this and see if we hit the required big O criteria. Excellent. We did pretty good here. So let's have a look at the big O nature of this question. Remember, Leetcode isn't just about getting the solution. You also have to talk about time and space complexity. So think about it this way. We've got 3 variables to keep track of our merge pointer and our pointers to nums1 and nums2. If we run this algorithm with 1 million records, will that grow? No, we'll keep on adding, setting just 3 variables. We're also not copying this data to any other arrays or anything like that. So when we talk about big O, in terms of space complexity here, this is O1. Okay, it doesn't even linearly grow with the data that comes in. Now, if we talk about time complexity, where are we at? It's pretty clear, as we're just going from the back to the front using our pointer, that this is O of n. We're not looping multiple times through multiple arrays and all that sort of junk. It's just O of n. Pretty clear cut. Well, that was a relatively easy one, although a bit deceptive if you don't know the trick of using a merge pointer and going from the back to the front. If you try doing anything from the front in the solution, I can almost guarantee you a fail. So I hope that helps. And I really hope you get this question in an interview. That'd be cool, eh? Please don't forget to like this video and also subscribe to my channel.